Hello everyone, welcome back to another video. Now we will discuss about velocity selector. Velocity selector is actually a device in which electric field and magnetic field are both balanced out. And when a particle moves through a magnetic field and electric field, it will go straight forward. It will not be deflected towards any direction. So let's consider two parallel plates, two oppositely charged parallel plates. The upper plate has a positive charge and the lower plate has a negative charge. And there's also a magnetic field acting into the page. The cross shows that the magnetic field is acting into the page. This plate is connected to a positive voltage, and this side of the plate is connected to a negative voltage. So now considering the particle moving into this region, as we know that the formula for electric force and magnetic force, when a charged particle enters into an electric field, it will experience force. When a charged particle enters into a magnetic field, it will also experience force. So for both of these forces, we have formula. For electric force, we have formula QE, and for magnetic force, we have formula Q, V, and B. Both of these formulas show that electric force and magnetic force acts upon a charged particle when it moves through them. So the positive plate will attract the electron, and the negative plate will repel the electron. If the magnetic field is switched off, then this particle will be attracted towards the positive plate, and it will be repelled from the negative plate. So we can say that if electric force is greater than the magnetic force, then it will move upwards. In another case, if the magnetic force is greater than the electric force, we use the formula FB is greater than FE, and F equals to E into V cross B. By using flaming left-hand rule, we will get the direction of force downwards. By using this formula, I can say that V, the first vector, is velocity, and the B, second vector, is magnetic field. By putting the left hand in the direction of the velocity and curling the finger toward the direction of the magnetic field, which is into the page, inward, we get the direction of the force will be downward. So if magnetic force is greater than electric force, the direction of the electron will be downwards. So by comparing both of these forces and by equalizing both of these forces, like electric force equals magnetic force, they both will cancel out each other's effect. Now the charged particle will move on in a straight line. Both of these forces will cancel out each other's effects. So this velocity selector is actually a device which is used in mass spectrograph. This device is used in mass spectrograph where all the particles have to move out at a particular speed in a particular direction. This device is used in mass spectrograph, which is, we can say, that is used to distinguish between isotopes of chemical elements. And we also use the formula charge to mass ratio E by m equals 2v over b square and r square, and also E by m equals to v by br. According to this formula, r equals to E b by m and v. So basically this is all for velocity selector. E by m equals to v by br, and by rearranging this equation, r will be equal to v m by be. So we can see that r is proportional to velocity. The greater the velocity of the electron, it will move in a larger circle, and r will also be proportional to the mass. The heavier the mass of the particle, it will move in a larger circle. And also we can see that R is actually inversely proportional to the magnetic field. The greater the magnetic field, the smaller the radius of the circle will be. It will tighten the radius or it will tighten the circle. It will move in a small circle as we increase the magnetic field.